In this video, I'm going to go through the answers for Quiz 2. So if you didn't do well on Quiz 2 or get them all wrong, whatever the situation may be, take a look at this video and we'll see if we can straighten things out. This first question refers to, actually the first three questions refer to a box plot. It's from a survey that I gave to a couple of classes of mine a couple years ago, where I asked them what year did Mark McGwire hit 70 home runs. And their answers are given in this box plot. The first question asks, which of the following represents the largest number of responses? To answer this, it would be helpful if I could actually draw on the box plot, which is hard to do here, but you could do on a piece of paper if you copied the box plot down. I'm going to use my original template for the quiz to show you this. The four ranges are from 1940 to 1960, 60 to 75, 80 to 90, 90 to 99, and 99 to 2000. Let me draw on here those four or those five ranges. So from 40, let's see, here's 1940. What was it? 1940 to 1960. So that would be from here to here. And then from 60 to 75, let's put one right about there. From 80 to 90, here's 1980, and here's 1990, and finally, oh wait, there's two more, 90 to 99, that's about where 99 is, and then 99 to 2000. Okay, so it's kind of hard to see exactly which ranges we're talking about here, so perhaps I should add some, here, I'll do this. So here's the first range, and let me adjust, give me a sec here. There we go. There's the first range, here's the second range. This is for question part B. Here's the third. Here's the fourth. And finally the fifth. It's that little sliver. So small that it's going to not look very big at all. Okay, so let's look at these four chunks here. The first one. This one, let's see, can I add some text to this? I think I can. Well, apparently not. Okay. Anyway, this first range is, you notice that the quartiles divide the data into fourths. And so from here to here, let's see, I'll actually put a text box up here. This is going to be 25% of the data. And it's going to go from the bottom end all the way up to that first quartile. All the way to right about there. So that entire range, all of the data here is 25%, which means that this box right here, that box, that range of data between 40 and 60, that's less than 25%. I don't know what it is. Might be 10%, might be 5%. It's less than 25%. This one's less than 25% as well. It's completely within this 25% bracket here. Okay, well, what about this one? This one is also within one of the quartiles, or the quarters. And so that's another 25%. So let's see. I will put another text box here. And we'll just label this as being 25% from there to about there. So this is 25% of your data from here to here, which means that this box is less than 25%. What about this one? Well, this one contains a full quarter. This is 25%, this little box right here. And so this range actually is more than 25%. This little sliver is just too small to be anything. It's probably 1%. So anyway, to recap, the first range from 40 to 60, that's less than 25%. I don't know what it is, maybe 5%, I don't care. This one from 60 to 78 or 75 or whatever it is, that's less than 25%. I don't know what it is, maybe it's 10%, but it's less. This one here, that's less than 25% because it's fully within 1/4 of the data. This one though, it includes 1/4 of the data, so it's more than 25%. Maybe it's 35%, but it's more than 25%. Finally, the last one, that little sliver, I don't know what that is, but it's probably like 2%. So to recap, the correct answer here is this 90 to 99, that biggest percentage, more than 25%. Next, it says refer to the following box plot. In which year did McGuire hit, okay, blah, blah, blah. If you know 19% of the responses were before 1970, then what percent were between 70 and 98? Let's go ahead and do this on here again. I'm going to delete some of this because we don't need it. Let me move this line over to 1998. There. Let's get rid of this, 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 this. Okay. So, what we're told is that 19% of the data is less than 1970. So that's that range there, 19%. That means if you look up here, 25% is less than 1978. So that leaves 6%. Just subtract 19 from 25%, and you get 6% belongs right here. Now, before we had talked about this, that that this is going to be 25% of your data. This is the second quarter. And in fact, this is 25% of your data as well. I guess I don't have enough room to put my 25%. Let's see, good enough. Okay, so here's 25%, here's 25%, and we know that this is 6% right here. So let's add it up. Between 1970 and 1998, there's 6% plus 25% plus 25%, which is 56% of the data. So put 56 there. The next one, the interquartile range. That's actually pretty easy. Interquartile range refers to the distance between the first quartile and the third quartile. So let me identify those 2 points. The first quartile is the beginning of the box. Third quartile is the end of the box. This is about 1978. If you said 1979, it's okay. Out here is 1998. So the interquartile range is 1998 minus 1978. That's 20 years, a 20-year span there. If you had typed 19 or 18, I think I still gave it to you there. Okay, moving on. To complete this problem, I'm going to need my calculator. So here's my calculator. Give me a minute to let it start up. Okay, so here's my calculator, and what we're going to do is, in order to compute mean and so on, we need to type in the data that we just that you have here. I did this earlier, so you can see here that I've typed my data into lists 1 and 2. So see list 1 and 2 there. You press stat edit. Here, let me just show you that again. Stat edit, and you can type in your data. Okay, there it is. See, it's all there. Anyway, then once you have that, press the stat button, go over to calc, press one variable statistics, and then you're going to choose list 1, which is second L1, and then comma list 2, because you have a frequency distribution here. So this is a frequency distribution, and then there it is. There's all the information you need. You have average, standard deviation of the sample, standard deviation if this is a population. If we scroll down, you get some other numbers that you care about, like the quartiles and the median. So let's just copy this into our quiz. 1.8 is the sample mean. Let's see, the next problem asks for the standard deviation with 2 digits. That's this one, 1.44, because it's the sample standard deviation, not population. The next one is asking if you were to construct a histogram, boundaries of the first interval would be which one of these? Well, the first interval should include the 0, and that's this one, will include the 0. You go a little bit below 0 and a little above 0. The next one, 40th percentile. To understand this, realize that your data is actually representing actual data. This frequency distribution, whoops, it actually represents data. So this frequency distribution means that there are 4 zeros. So the actual data looks like this. There's 4 zeros. Whoops. That's what I want. There are 8 ones and 7 twos. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. You got enough there. There are 3 threes, 2 fours, and 1 6. And there are no 5s. So there's all the data. There's 25 observations there. To compute the 25th percentile, or the 40th percentile, the first thing we need to know is the position. So we do 25 times 40%, but write it as a decimal. And it's position 10. And if you watched the percentile presentation, you'll know that you're going to average together the 10th and 11th position. So let's go back to our data here. And we do, let's see, there's 4, 5, 6, 7, 8, 9, 10, 11. So the 10th position is this one, and the 11th position is that one. So I'm going to average these two numbers together, and that's easy. 1 plus 1 is 2, divided by 2 is 1. So my 40th percentile is 1. You could have figured this out without writing all that down. You just count up, there's 4 zeros, and then there's 8 ones, so that means that the ones occupy positions 5 through 12 in your list. And it's the same as what I had here. At any rate, let's go and do the 90th percentile. To compute that, we need to know what position to look for. That's going to be 25. 25 times 90%, so 0.9. 22.5, and whenever you get a decimal, you're going to round up. So we want the 23rd number on the list. Let's see if we can figure it out using this instead of using this. Now, you could always use this. That's fine. So I want the 23rd number. Here's 4 numbers. There's 4 zeros. Then there's 8 ones. That makes 12 numbers. When we include this 7 twos, that brings us up to 19 numbers. And then we get 21 numbers. I'm sorry, 22 numbers when you add in the 3s. The 23rd number should be a 4. We can double check this here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 23rd number is a 4. You can count them up if you want. I know it's the correct answer. So the 23rd number is a 4. Finally, 2 more questions, multiple choice. If you have 1 or 2 extreme scores to a high end of a distribution, it has a great effect on, well, this is just the mean. The mean gets moved by extreme values, but the median stays in the middle. Kind of makes sense. If you're to, you can test this out. Take 5 numbers, like 1 through 5, average them together, and then change the 5 to 1 million and average those together. You'll find that the new average is much bigger than the old average, but the median stays at the number 3. So it's always, the median always stays in the middle. So this is, it's going to affect the mean, but not the median. Finally, whenever a distribution is skewed left, what's going to happen? Well, let's draw this. I'll do a poor job here of drawing. Insert. Let me draw a skewed left distribution. Skewed left looks something like this. There. So there's a skewed left distribution. In a skewed left distribution, the mode will be at the top, the big number there. The median will be a little bit to the left. Remember that the median is going to divide your data. Here, I should put a bottom into this. Let's see. There. That looks better. So this median, you want half the stuff to be on the right, half the stuff on the left. Finally, the mean. The mean will always be pulled in the direction of the skew. So here, let me just put these, label these things. This one is going to be the mean. This one's the median. And this one is the mode. Okay, so which one's the biggest? Looks like the mode. So the mode is the largest of those. Yeah, these are just silly answers here. You don't need those. All right, that's it. I hope that helps, and I hope that you get a 20 out of 20 on quiz. Let's see how I did on this one. I'm pretty sure I got a 20 out of 20. Okay, submit. And sure enough, yep, 20 out of 20. Hopefully you'll get that on quiz 2B if you try it. All right, thanks for watching.